Hey there, guys. Mr. Jenkins back again with another Algebra 2 lesson. This one is called the Quadratic Formula. This is going to be lesson, let me get to the right page here. I believe it's 4-7. So second of 4 lessons that we'll cover in our current unit. So we got into yesterday. Well, see if we can get this to work first. There we go. We got into yesterday kind of talking about finding solutions that were irrational number solutions. So solving by completing the square is one way to do that. Solving with a quadratic formula would be another way. Okay. Quadratic formula is nice in some ways and not so nice in other ways. I guess the not so nice way would be because here it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's all kinds of fun songs and stuff that help you remember that. But anyways, the nice part of it is it works on any and all quadratic equations. Okay. So our learning target would be that I can solve quadratic equations using the quadratic formula. So another key concept would be the discriminant. So we'll talk about that first. Basically, we can tell how many solutions a quadratic equation has just by looking at its discriminant, which is just the part under the radical. All right, the b squared minus 4ac. Okay, so there are 3 outcomes. If that number is greater than 0, you have 2 real solutions. If that number is equal to 0, you have 1 real solution. And then if it is less than 0, you have 2 complex solutions. We'll get into what that means later. All right, so for example 1, we just want to see how many and what type of solutions do we have. All right, so first things first, let's identify A, B, and C. A is equal to -3, B is -8, and C is 16. So then we just want to sub in to b squared minus 4ac. So -8 squared minus 4 times -3 times 16. b squared minus 4ac. All right, when you type that in, you do want to use parentheses. So -8, or you could just type 8 squared. -8 squared and 8 squared are the same. Minus 4 times -3 times 16. That's equal to 256. It doesn't really matter what it is equal to. It just matters that that number is greater than 0. So then we're looking at this case right here. So we have 2 real solutions. All right. If we, basically, if we're thinking about a graph, we know we would see 2 x-intercepts there. Looking at number 2, same kind of deal. B squared, so that'd be 1 squared. Notice I didn't use parentheses there because that's positive. Minus 4 times A, which is 4 times C, which is 2. 1 squared minus 4 times 4 times 2. Equals negative. Doesn't really matter what I say after negative. Equals -31. So negative anything falls into the less than 0 category. So this one has 2 complex solutions. And there was a time where we would just say that would be no solutions, but we're going to get into complex numbers going ahead. So this would be, if we saw a graph, either a graph, well, I can tell you, it would be a graph that opened up that starts above the x-axis, right? So if it opens up and starts above the x-axis, might look something like this, then you have no x-intercepts. Okay, that's what we're saying. And let's see, what else? I think that's about it. Oh, just as far as identifying, is it going to be positive or negative? You can kind of tell pretty quickly. Like on this one, your number squared is always positive, and then you have minus and then a negative, right? So this ends up being plus all this. Positive plus something is going to be positive. This one squared is really small, and then minus a positive, right, is going to be negative. So you just kind of learn to use little tricks like that. But that's the discriminant. Now we're going to look at things more graphically. Okay, it says use the discriminant to match each function with its graph. So I kind of like this one. So we'll look at number of solutions based on the discriminant and try to match with the graph. So make sure we're looking at the right thing first. On this first one, this is my y-axis, this is my x-axis. It's kind of hard to see with that line right there. Same kind of deal here. Y-axis, x-axis. Okay, so let's go ahead and see. So hopefully you can look at this visually and tell, based on what we've done with solving by graphing, this is a no solutions. This is a two solutions, right? Because two x-intercepts, and this is what a one solution looks like. Okay. All right. So let's go ahead and use the discriminant to see what goes where. All right. So this one would be negative 4 squared minus 4 times 1 times 2. So that's going to be 16 minus 8. That's going to be positive. Be 8. So positive means two real solutions. That would mean that this has to go with A. Next one, b squared is negative 4 squared minus 4 times A, which is 1, times C, which is 4. This is 16 minus 16, right? So that'd be 0. That's our one solution. So B would go here. And we know that must mean C goes here, but let's go ahead and see why. So you got b squared, negative 4 squared minus 4 times 1 times 6. So in this case, we have 16 minus 24. So that's going to be negative 8. Didn't matter what I said. Once I said negative, that would be two complex solutions, also known as no real solutions. So no x-intercepts. Okay. So hopefully that makes sense kind of when you see it graphically. All right, now let's do a couple, and then I'll leave a couple for you. It says solve using the quadratic formula. All right, so let's go ahead and do that. So this is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so I'm going to show it with everything subbed in first. So x equals negative 5 plus or minus the square root of b squared, so negative 5 squared minus 4 times 2 times negative 3. All that is divided by 2 times a, so 2 times 2. Got to get used to what's a, b, and c. All right, so I kind of show the next part in 2 steps. I figure out what my discriminant is. So negative 5 squared, I'll just type that in as 5 squared, save myself a little time, or 25 minus 4 times negative 2 times negative 3. So that's going to be 1, right? So again, think about your signs here. This is positive. Then you have 1, 2, 3 negatives there. So that's going to make that overall negative, right? So basically you have 25 take away 24 there. So now we have starting to simplify. Negative 5 is 5 plus or minus the square root of 1 all over 4. So simplify that as much as you can. The square root of 1 is 1. Okay, and then we need to simplify to get both solutions, right? So 5 plus 1 would be 6. So you got 6 over 4. Six over 4 to be 3 over 2. That's one of our solutions. And then you have 5 minus 1 is 4. Equals 1. So 1.5 and 1, it looks like, are our two solutions there. And it looks like I'm going to have to cut that out. I did something wrong. So let's try that again. Always use your notes, kids. All right, so now we're going to solve number 1. Okay, identify A, B, and C first. A is 2, B is -5, and C is -3. All right, so remember it's x equals -b. So -5, I'm just going to write that as 5 plus or minus long square root symbol. B squared. So that's -5 squared. Really, I would just write that down as 5 squared minus 4 times 2 times -3. All of that is over 2a, so 2 times 2. All right, now we start to simplify. Okay, so I'm going to go ahead and figure out what's my discriminant. So 5 squared minus 4 times 2 times -3. It's going to be 49. So I have 5 plus or minus the square root of 49 over 4. Okay, now it comes to simplifying. So the square root of 49 is equal to 7, right? So that part equals 7. So then we have 5 plus 7 over 4. That'd be 12 over 4. So 3 is one of our solutions. And then 5 minus 7 is -2. That'd be -1/2. All right, so those are two solutions right there. So we could say x equals -1/2, comma 3. I think that's how Math XL likes you to enter those in. All right, let's look at, we'll skip number 2 because obviously I wrote all over that. I think number 3 is another type that I would probably need to show you. I think you guys have seen this one in Algebra 1, so you may be more familiar than what you were with the last lesson. All right, let's go ahead and get to it. X equals -b, so -6, plus or minus long square root symbol. B squared, so 6 squared minus 4 times 1 times -5. All of that over 2 times a, which is 1. I'm going to work down here since I don't really have any room over to the side. All right, so -6 plus or minus, let's see what our discriminant is. So 36 is 6 squared minus 4 times 1 times -5. So we get 56. That's the square root of 56. Remember, I just simplified what was under the radical. All over 2. Okay, now we have to simplify that radical. Obviously, 56 is not a perfect square, but then we would want to know what is a perfect square that divides into 56. So I just kind of try, if you know your perfect squares. So, maybe do 56 divided by 4. All right, so 4, that's how we would divide it up, 4 times 14. So, like I said, we can work on simplifying this a little more in class on the DMR. Feel free to ask about it if you're having trouble. So that gives me -6 plus or minus. Square root of 4 is 2, so 2 square roots of 14 over 2. All right, then we want to simplify everything we can here, right? So this, and this can all be divided by 2. So I'm going to go ahead and do that. Divide them all by 2. And we would get that's a 3, that's a 1, and that's a 2. Or sorry, that's a 1. So really this simplifies to, I'm just going to rewrite x equals -3 plus or minus. I'm not going to write 1 square root of 14. That'd just be the square root of 14. And it's over 1. So we would just keep it as -3 plus or minus the square root of 14. Okay, so obviously those answers are a little bit harder to understand, but that is what we're looking for. And I will leave the rest for you. So there's a number 1 you could do there, a number 2 you could do there, and there's that number 2 if you wanted some extra practice. If you wanted to just pick one, I would say maybe do number 2 because there's an important first step that we haven't really seen yet. Okay, so I'm probably going to ask you about that one. Thanks, guys. Hope this helps. Y'all have a nice day.